Hello ladies and gentlemen, what's up? This is Papa Bale and welcome to the channel. So I'm going to be discussing real quick in depth the 1, 2, 3 that I keep talking about. And this is just what I'm calling this circuit. So in order to make it function properly, you need a transistor that goes base, collector, emitter from left to right. So BCE facing when you're looking at the transistor's front end. So as it is in the 1, 2, 3 currently. Okay, so here we have our battery or power supply, our coil, bifilar coil. Doesn't need to be a bifilar coil, it just needs to be, if it's not a bifilar coil, it needs to be 2 coils. Wherever you have the other magnet on here, it needs to be lined up with that. Anyway, with the bifilar coil, you get your connections, and you got your trigger here on the left, and then you've got your drive on the right in the diagram. So let's go through the connections real quick. We got base connection, goes straight up to the positive end of the trigger, and the negative end gets connected to the emitter. So trigger goes from base to the trigger, and then from the trigger to the emitter. Then the collector, the positive end of the battery, goes into the collector. And then this light up here is a 120 volt halogen light bulb. You need like at least 120 volts. It's got to be incandescent. It's got to have a filament, is what I'm trying to say. You know, it's got to be 120 volts. And one side's connected to the collector, and the other prong or side of this, or the external casing, is connected to the emitter. So collector, emitter for the light. So now we have the trigger connected and the light connected. And that will give us 1 here, 2 here, and then the emitter is connected to the drive coil. And that's your last dot here, or connection on the emitter to the drive coil, and then is grounded to the battery. And there's your nice little closed circuit. And here it is, one variation of it. So I stuck it in this thing to elongate each leg of the transistor. I'm just making them longer with more area to clip stuff onto them, because that's how I'm doing it right now with clips. I know that's a terrible way to do it. I'm thinking about investing in a soldering gun. So we got our base connection, which is the trigger, and you notice that even up here there's no connection except this one right here, the green one. So that's 1. 2, we got this is hooked to the power, and this other clip is hooked to this light. You can't really see it, it's right there. Okay, and then the third one, you got your ground for the trigger, you got your connection to the coil, and then you got your other connection to the light. 1, 2, 3. 1, 2, 3. BCE. And of course, you don't have to have BCE, but then it's not going to be 1, 2, 3. It's going to be like 2, 1, 3, or 2, 3, 1, or 1, 3, 2, you know, it's not going to be really crisp. So this is the power supply that it's connected to. We'll go 9 volts. And it's nice and smooth. Just listen to that. It might have something to do with the coil that I'm using, but it's smooth. It might not be the fastest in the world, but it goes pretty fast and it's smooth. But it picks up to the speed really quick. I think it's max right now. So I'm going to turn it up now to like 12. We're going to get that light lit up because right now currently there's not enough juice going through it to even utilize the resistance we do have. So 12 volts. Yeah, we're getting it now. Look at there, it's lighting up. That's sweet. That's 12 volts. And yeah, it is. Sometimes it's cumbersome working with moving parts. That's why I'm kind of wanting to, you know, chill out for a minute and try something new. So I'm eventually going to get a soldering kit, and we'll go from there. But that, look at how smooth. Just that is so smooth. I got nothing bad to say about this. So cool. All right. And because the coil bobbin is made out of iron infused PLA, it will slow down relatively quickly. And then we got our kind of rotator here. Let me give this one a whirl. So it helps when you nudge it along. Yeah, that's whipping right along. Woo! It's going pretty fast. The bottom is not going as fast as the top, but it's going a lot faster than it usually does. And then, I mean, every time it hits, it pushes it along, but it weighs so much more than the one on the top that it's going to move slower. But every time it hits in the right spot because the trigger coil is timed correctly. So cool. All right. And I think with the added weight that I added on, that was designed for the dual drive, which is now a single drive, I can show you. See, there's only one transistor in the breadboard. That's for the 20 gauge. The 32 gauge isn't working properly right now, so I'm not going to throw a bunch of transistors in there just to burn them up. I'm probably get a resistor for it. Got 2 resistors right there. It does for the trigger, I'm pretty sure. Yeah. All right, and then I have a light bulb right here that I can put in that circuit. I just when I put it in this circuit, and that's the only one I've done yet, the one that doesn't have a transistor, it would be on the minute I put it in there. And that's not what I'm looking for. I'm looking for it to be on when it's running only. And it might not do that because of the 24 volts and the breadboard. The combination of those two, it doesn't work well, I don't think. But I mean, I'm making it work right now. I'm not saying it doesn't work. I'm just saying that there's a way that we can make this work better. But it's very simple. You got 3 connections currently per circuit. You got your, all we're missing for 1, 2, 3 is the light bulb. We got 1, 2. Actually, I think we're just working with the 1 because it's a dual trigger. The positive end has 2 and the negative end only has 1, and it goes in where the battery grounds, if that makes sense. And the way that we make that happen, so we've got these clips right here. So it goes in as 1 or it comes out as 1, and it goes in as 2 or comes out as 2 on the other side. And that's ends to your wire, or whatever it is. Definitely a wire, but of your connection. So yeah, again, very cool. So maybe I'll put that light bulb in there. But I think it's working pretty good. I just think the bottom can move a little bit smoother, because I think it slows down. It starts slowing down after a given point. It may just because the batteries are low. Not exactly sure, but I do know that it starts slowing down. And we're going to try and negate that. As long as there's juice in the tank, we should be able to negate it. So I'm going to start by putting this light in this circuit over here, making it a 1, 2, 3. Awesome. So the 1, 2, 3 over here works really well. You can put 12 volts into it easily. It does require a little bit more energy, I think. I mean, I can't really say that. This is a pretty unique coil, and the coil itself probably takes a good amount of energy to run. Yeah, I don't know. And compared to another coil is what I'm saying. So I don't know. Without doing a bunch of tests, I can't really say. I just think, I know it's quiet. I know it's fast. It's not super fast. It's fast within the paradigm of what I'm doing here. Anything else just doesn't matter. And I know other people feel exactly the same way about what they're doing. I'm just trying to explain what I'm doing here. That's it. And I think it's good. This and the reason I'm like, because this is a Litz wire coil. It's all twisted up, and then all the rest of them are like straight. So yeah, you're gonna get a different reading per different coil. But if I ran the same test on that coil 3 times, and like even ran it with the same voltage, I might get different RPM readings. All right, so I'm going to turn this on one more time, and I'm going to wrap around, show you the circuit again. And that's with a aluminum load on it, pretty much, and a copper load. Because that coil is shorted into itself with a diode. So, and then here it is in a nutshell. So you got your 1 connection, 2 connections, 3 connections, and your ground, which I do not consider part of the 1, 2, 3 necessarily. That's just what's touching the transistor right here. 1, 2, 3 ground, basically. Alright, thank you very much. Peace out. Have a great day. Please subscribe. Bye now.